So this is a simple robot that is intended to navigate an apartment. You can see it has like these basic spoke wheels. So this thing is electronically separated. This unit is a Raspberry Pi. The one back here is a Arduino. It's like an Arduino, and it has a ESP01. You can see here. So that's the Arduino right there, and that's how those two talk to each other without having like wires between them. Because the idea is that the head unit separates. You can see here that it does. Carefully. Yeah, so this thing is completely separate from that. And I actually dropped this thing the other day, unfortunately, and it broke the battery holder. But I dropped it from like 6 feet in the air. It's pretty bad. But anyway, and then so we go to the sensors, the navigation head. So looking at the head here, you've got a TF Mini S. This is like a very narrow beam. It's like 2 degrees. Then you've got one of these VL 52 LOX or whatever. 53. This one is super wide. It's like 25 degrees. This is an 8 megapixel camera. When I made this, the camera was upside down, so I kind of had to like break it to put it in the right orientation. That was unfortunate. And then if we turn it sideways and look inside, if you look on the very middle of the pan, or the tilt in the pan axis, there is a 9-axis accelerometer in there, or IMU I should say. Gyro, accelerometer, magnetometer. That's the 9 axes. It's hard to see. Wait. Maybe. Oh, there you go. You can kind of see it there. Anyway, I was at the very middle, and then underneath is a boost converter. That blue thing right there. That turns the 3.5 volt 18650 cell to 5 to power everything. So that's the navigation piece right there. In the back, the drivetrain is very basic. It's a tail dragger, 2 servos, both go forward, opposite directions to turn. And the build is the same, like 18650 cell, goes to boost converter, steps it up to 5 volts, and then it feeds everything. There is a regulator there, linear regulator. It drops it to 3.3 volts to power the ESP01. But yeah, so and there's servos, so there's no like motor drive or anything. The servos are powered through like a separate bus, or they're powered through this converter here, so all the Arduino is doing is just controlling them through the yellow wires. So yeah, that's the hardware. You can see it rotates, and this part tilts up and down. And then this is vision based, so it takes like 15 images, produces a panorama, and then from there you can segment things and measure distances and whatnot, and then in theory track displacement from the IMU. But that's a design flaw, having the IMU there, because this thing wobbles when it moves, so that's something you have to like filter out. So this video is about writing the software from scratch, and here you can see all the base components And I've actually written code for this already a long time ago. See, like 2 years ago. And I've learned more since then about like coding in general, structuring. Oh, sorry, this is for the video resolution, but yeah, so what you want to do is build up on like units, blocks to make systems. So if you think about it like this, where this is the navigation unit and this is the body, and inside that you've got I mean, you could mimic what's on the left there, but and then this talks to that, this talks to that, this talks to that, this being the pi. The body is similar. Got the two servos there. This is the Arduino, just like another Arduino thing. It's just tiny. And USB-C. So this thing here is called like GPIO, General Programmable Input Output, something like that. And each hole or connection has a purpose, which you zoom into it. See, some of them are ground. That's the black dots, and then red is power. Orange is the lower voltage, 3.3 volts. And these pins can only supply 50 like milliamps. Not a lot. Like, you're not really trying to power anything from these pins. Maybe an LED with a resistor. But the point is just knowing what these GPIO ports are, and then the communication methods. This right here, I2C or serial, that's one. SPI is another one. And I primarily use I2C. It's like simpler to me. And when you look at components like the VL53 right here, the wide angle, and then this is the 9-axis IMU accelerometer gyro. So you see on the pins here, VCC, that's voltage, ground. You would connect those. But the clock and the, I think, data, SDA, like, those are what you use for the I2C when you connect them together, like data, clock, yeah. And then I2C, I won't explain too much about it because I am not that well versed, but if you dump the like I2C channel on a Pi, it has like multiple channels, so you can put different devices on there, but they have to have a unique address, or you have to do some like hardware to set them manually, which I've done that before in the Trilidar mouse project. But here they're separate. It's like 69 or whatever the address is. Similar for the TF Mini, same thing. It's like a 4-wire interface, power connection. But yeah, so you connect those, and similar for the servo. The servo is driven, I use the like Arduino servo library. That's easier than dealing with PWM manually. You can see that up here. But again, it's like the Arduino has these ports like 5-volt ground, 3.3 analog and digital. Those are different. Analog, if you want super resolution, or like 0.37 volts, that's what analog is for. Digital is like it's on or off. When you use analog, you usually have to tie it to some range and then divide it by 1024 or whatever to get the division. Anyway, that's not important here, but you can also see UART. That's I believe that's serial TXRX, but there's also, you know, I2C as well. So yeah, the servo gets connected there. The power is shared from that step-up converter, and then the important thing is like all the ground is shared. That's how the communication between the stuff works. Of course, these are isolated like electronically, because as mentioned, oh, I didn't put an ESP here, but the ESP01 is here as well. So anyway, you've got your parts and you know like what has to talk to what, and then each thing is like an API where the Pi can just ask it for stuff when it needs it, because the Pi is doing the thinking. So, and also like here you need a like servo API, but the Arduino is like directly talking to them, so you don't really need this kind of thing. But you know, it's like the sensors here, you tell them like go, and they have to do that part, so they have their own, you know, set of code. So yeah, and then the way I structure my code, the folders, it's usually contextual, like the name of the component, so you'll see that. And if you see the old code, I follow that kind of design. Like, oh yeah, this thing has a web interface. You can manually control it and see the camera from. And then, yeah, so if you go to Raspberry Pi, this is all the code that's related to, you know, these sensors that are connected. And again, I'm not going to reuse this, or I'm not going to use this code. I'm going to use some of it because it's like straight up library calls. And I remember I had to figure that out in the past. You can see different stuff I was testing out here. But that's the plan of action, or how you would go about doing this. And as far as like Python importing, that can be problematic. So I usually follow this pattern where there's like a main file and then it has sibling folders, and the main file imports from all these folders. So if you open that, you see all this syspath stuff I was doing before. That's kind of sus, but yeah, and class-based code. I'll get into that more once I actually start writing code, but yeah, so that's what you want to do, is break the problem down and then start building each piece.